Good morning, students. I am Manikant Mishra, Modern English School, New Area. My sincere, heartful thanks to all of you who really wish to me on the occasion of Teachers' Day. So once again, many thanks to all of you. So last week we are discussing about the classification of elements. In this regards, the different efforts made by different scientists. Like very first effort made by Lavoisier, thereafter Darwinius, and then Newlands. So each classification, though we say that becomes unsuccessful, but in spite of being, gives a clue for the next scientist. With that clue, that he further tries to modify the things. So today we are going to discuss about the Mendeleev's classification. He is a Russian chemist, Dmitry Ivanovich Mendeleev. His name is Dmitry Ivanovich Mendeleev. He is a Russian chemist. His contribution is an immense contribution in the classification of elements. That's why he is also known as father of the periodic table. Mendeleev is known as a father of the periodic table. He tries to arrange the elements on the basis of the fundamental properties of an element. So he was trying to arrange the 63 elements, and keep it in mind that time the inert gas were not present. So before he arranged the elements, he studied about the physical and chemical properties of an element. And as far as my concern of knowledge, he focused in the beginning of while studying the elements, his focus was, he stressed more on the study of the chemical properties of an element. And also regarding the chemical properties of an element, he also laid more stress with the hydrogen and oxygen. He studied the chemical properties with oxygen and hydrogen and forming a compound so called oxide and hydride. The reason was these two elements are quite reactive, and it reacts with most of the elements and forms oxide and hydride. After studying the physical and chemical properties of an element, that he got clue from their chemical formula. He made 63 cards, and for each card he started to write the chemical formula of hydride and oxide and properties. Once he mentioned the physical and chemical properties of 63 elements on 63 cards. The next job was, now to sort out all the cards or arrange the cards. Out of 63 cards, he tries to make a group, put it into a group. So while sorting out, while arranging, while making the elements having the similar properties in each card, he found that the elements having the similar physical and chemical properties are coming together in the order of increasing atomic mass. What I said? He studied the physical and chemical properties of the elements. He wrote the formula of oxide and hydrides of that particular element. As for example, if I say, like, if lithium combines with hydrogen forms lithium hydride, LiH. Sodium reacts with hydrogen forms sodium hydride, formula is NaH. Similarly, sodium reacts with oxygen, forms sodium oxide, formula is Na2O. Some other element like magnesium reacts with the hydride, forms MgH2. Magnesium reacts with oxygen, forms magnesium oxide, MgO. So, at the top, in general form, he represents the elements as with R. Instead of, in a general form, I am saying at the top you see R2O, RO, R2O3 or RH. R, what it R represents? Name of the elements. Name of the elements. As I said, here R represents lithium, like lithium, sodium. Here R represents magnesium, calcium, magnesium, calcium. Like this way, R represents the name of the element. So, the formula of hydride, formula of oxide, he wrote on the card. He mentioned on the card. So he formed 63 cards for the 63 elements. And the next job was, he was trying to sort out. Sort out means the elements which have the similar chemical formula. Elements which have the similar chemical formula. As for example, lithium hydride, LiH, sodium hydride, NaH. Lithium oxide, Li2O, sodium oxide, Na2O. Magnesium hydride, MgH. Magnesium oxide, MgO. Calcium hydride, CaH. Calcium oxide, CaO. So you see that what is happening? Here you see the hydride of sodium and lithium have the similar formula, similar RH, R2O, RO, RH, RO. So like this kinds of magnesium oxide, calcium oxide, magnesium hydride, calcium hydride. So that elements which have the similar chemical formula of hydride or oxide, he tries to put in each group. He made the cards having the similar physical properties and similar chemical properties in each group. After making a group, he found that the elements having the similar properties, physical properties and chemical property, while arranging the elements on the basis of the similarities of their properties, that follows in the order of increasing atomic mass. Then he has given a periodic law that is popularly known as Mendeleev's periodic law. What is a Mendeleev's periodic law? After doing this effort, after making such effort, then only he generalized that physical and chemical properties of an element are the periodic function of their atomic mass. After sorting out the 63 cards, they placed in different groups. What he made is, he made 8 groups. So it means 8 types of group he has developed. All the 63 cards has been distributed in 8 groups. All the 63 cards, while arranging, he found that there are 8 varieties are developed. That's why in his periodic table there are 8 groups. There are 8 groups and 6 periods. My dear student, what is a group? Vertical columns are called. In the Mendeleev's periodic table, there are 8 groups and 6 periods. Now, my dear student, what is a group? Vertical columns are called group. Vertical column are called group, like a 1, 2, 3, 4, 5, 6, 7, 8. So these 8 vertical columns are called group, and the horizontal rows are called period. Horizontal rows are called period. Vertical columns are called group. Horizontal rows are called period. So in the Mendeleev's periodic table, there are 8 groups and 6 periods. Elements having similar properties are placed under the same vertical column, so called group. Elements having the similar properties are placed in a group. So there are 8 group, 6 period, and there were 63 elements present. Now each group is further divided into A and B. Subgroup A and B. Each period is subdivided into A and B, A and B, A and B, A and B. Like this way, each group is further divided. And in 8 group from 4th periods, 3 elements are placed. Like here you see iron. In a 4th period, it starts. These elements start from the 4th periods, and in 8th group, 3 elements are placed. Iron, cobalt, nickel, ruthenium, rhodium, palladium, osmium, iridium, platinum. Iron, in a 4th period, 3 elements are there. Iron, cobalt, nickel. Similarly, in a 5th period, ruthenium, rhodium, palladium. 6th period, osmium, iridium, platinum. So in this way, he tries to arrange all the known element. What I said? What is a Mendeleev's periodic law? The physical and chemical properties of an element are the periodic function of their atomic mass. So keeping these things in mind, he tries to arrange all the known elements. His confidence was very high. So while classifying the element, he has taken a risk at several places. Like that below boron elements were not present at the time. The elements were missing. So he left the gap. Similarly, below the aluminium, the elements were missing. So he left the gap. Below the silicon, the elements were not present at that time. So he left the gap. And tentatively he kept the name also. What he said? Eka boron. What is Eka boron? This elements next to boron or the preceding element of boron. So Eka is a Sanskrit word which means one or preceding element. Preceding element of boron is scandium. Later on it was discovered, but that time he has said Eka boron. Similarly, below the aluminium, the elements were missing. So he said Eka aluminium. And below the silicon, the elements were missing. He said Eka silicon. Not only he left the gap, but he predicted the properties of those undiscovered elements by studying the properties of the adjacent elements. Not only he left the gap, but he predicted the properties of those undiscovered elements. And it was found that later on, when those elements were discovered, what the properties he has predicted was approximately equal to that. So that's why I said in the beginning that Mendeleev's contribution is one of the greatest achievements in the field of chemistry. So while arranging the elements, Mendeleev was guided by two factors. One, placing the elements having the similar properties together. The second thing, increasing atomic mass. What I said, he has kept two things in his mind. The similar elements placed together, and second, increasing atomic mass. So one of the example here you see